My name is Spencer Gibb. I have been on the Spring team for almost 8 years, lead the Spring Cloud team, and I love it. I've been working from home for a lot longer than the rest of the world, so really enjoy it. So we're going to talk about Gateway today and show some demos and recipes of things that are fairly common in Spring Cloud Gateway. So I'll do a brief introduction of Gateway, just if you're not familiar with it, we'll get a little bit background and how it works. And then I'll basically show a few slides about what the project I'm working on looks like, and then we'll kind of go through some code and see how things work. All right? If you have questions, just go ahead and ask, or you can wait till the end. Either way, I'm fine. So let's talk about Gateway to begin with. Who's familiar with Zuul? Anybody? A few, yeah. So when I first started Spring Cloud with Dave Sire, Zuul 1 was one of the things we integrated in Spring Cloud Netflix. It's what Netflix used as their gateway on Amazon. And when Netflix blogged about Zuul 2 and the Spring team was building Spring Framework 5, which included the new WebFlux stack based on Project Reactor, and I had looked at the code and I thought, this is going to be such a pain to adapt, right? Because of the way it was built and the way Spring 5 was built. So we decided we could provide a better developer experience and just reuse a lot of the things that came with WebFlux. And so that's what happened. So we have Reactor Netty underneath, and Gateway is all non-blocking. The configuration is per route, where Zuul, there was just kind of configuration, and if you wanted it to match a particular route, you could, but basically they were kind of global. We have a bunch of built-in predicates and filters. You can match on anything in the request, basically. And then you can manipulate the request and make it so that you present a unified API to your clients, but then on the back end, if it needs to go to one place or the other, or things need to change a little bit, you can certainly do that. There's built-in support for other Spring Cloud abstractions like service discovery, client-side load balancing, things like that. There's support for metrics through micrometer and distributed tracing. So here's what it might look like in configuring some YAML. I show this because I'm not going to do any YAML configuration today. But I'm sad Bruno Burgess isn't here. He'd complain about YAML. Of course, this could all be in a properties file too if you don't really want YAML, but it's nice. So this matches this particular host and path, and you can do HTTP methods, add headers, rewrite the path, do all those kinds of things. And we'll do some of those today. But more we'll see things like this, which is a Java DSL that you can use to configure Gateway. So kind of just a high-level look of what's happening inside Gateway. One of the things that we were able to take advantage of is Spring Framework's handler mapping. So we have a custom handler mapping that allows us to match on these predicates and load them for different routes. And we also have a handler so that we execute filters, pre-filters and post-filters. If you're familiar with Zuul, those were whole separate entities, but in Gateway, you can have one filter that does pre and post, but we tend to keep them separated. And then there are a set of global filters that apply to all routes. And these are the things like, if it's a WebSocket, if you noticed here, we can do WebSockets. For example, if it's a WebSocket request, use the WebSocket filter. Otherwise, use the Netty HTTP filter, those kinds of things. This is where load balancing would happen. Metrics and tracing also happen in global filters. And then things get routed to the downstream services, and this is all with Reactor Netty. So it's an event loop. So as you wait for the response, things keep going. The requests can come in. So the first thing we're going to talk about is Backend For Frontend. If you're familiar with this architecture, it's basically an API gateway for a very specific front end. So it might look like this. You might have multiple clients. The classic example I use is for Netflix, right? Every one of their devices that they support or device classes is owned by one team. And so they have their own specialized backend for the front end. And then that's the thing that goes and talks to all the different services. And they do have you'd have a general gateway in front. And so they do have Zuul running in front of their backends for front ends. But could be any type of device, desktop device, mobile devices, set-top or TVs. I should have added game consoles, right? There can be all sorts of things. And the nice thing about it is that kind of following Conway's law and the natural organization of your teams, right? The team owns this and they can make the changes quickly rather than having one team that owns the gateway and they have to go through that team and caused a bottleneck. Sam Newman, there's a link here, has a pretty nice description of this and some of the use cases that come up. I'm going to combine the demo with my next bit here, so we'll have two demos for one here in a minute. But it's a nice pattern that a lot of companies have used. The next one is securing gateway with Spring Authorization Server. So the Spring Security team announced a new project called Spring Authorization Server. Has Joe talked about that yet? Is it coming up later? Yes, so at 2:20 in room 412, Joe Grandjo will be talking about, he's the lead on Spring Authorization Server. So he'll be talking about this project in detail, but I wanted to be able to show it to you. So the demo that I'm going to show is heavily from Steve Rissenberg, one of the Spring Security team that's working with Joe. But so what we have is Spring Authorization Server. This is the thing that authenticates the user, validates tokens. We'll get the gateway. Gateway is configured to redirect to the Spring Authorization Server for authentication. It also has a special filter that forwards the token to the downstream service. This is just a very simple messaging service, and it validates the token with Spring Authorization Server. So that's how all things work. And our front end, in this particular case, is an Angular app that I did not write. So most of this demo is done by Steve. They did a webinar that you can find, I think, either on the Spring.io blog or VMware Tanzu page. So let's walk through some code here. So this is, I'm running a fork of the authorization server. The interesting thing here is configuring the OAuth 2 clients. They use a JDBC repository. We'll see these scopes a little later, reading and writing scopes. sets up let's see, I thought the user was in here. Oh, I think it's in here. So the default user that we'll be using is here. This particular YAML file, I will show a little YAML. This is from the message, the downstream resource. This is the service. I just wanted to show that this is how you configure the downstream service to validate the JWT token. The message controller is just a little static Git mapping. But the other bits here on the, let's see, oh, sorry. So also on the message source, here we're configuring Spring Security using its DSL, and we have this expression, so we need to be able to have the read attribute from the user. And then we configure the resource server to validate the JWT token. And then I will show a little bit of, it's not JavaScript, it's TypeScript, but that's all right. The class that makes the call to the message service, we use get, but if it comes back with an error, we redirect to the Spring Authorization server. So let's see if we can get this all running. So I'm going to start the Angular client first. Okay, so the Node.js is running on port 4200. We'll go ahead and start the authorization server. Of course, it's doing a build. I went through this hoping that it would avoid all that. So the authorization server running on port 9000. We'll start our backend service. So we've got 3 out of the 4 boxes from our diagram, right? We've got this one, and this one. We still need to look at the gateway. Okay, so there's the message resource on port 8090. So now let's go to our gateway. So this is just a Spring Boot app using Spring Cloud 2021. And so these are the dependencies you need to do this. Of course, the gateway, but then the OAuth 2 client from Spring Boot that configures the appropriate Spring Security bits. The gateway running on port 8080. And here, this is the important OAuth configuration here. So Spring Provider, our client ID and secret. We're doing an authorization code grant type. And then this is the redirect URI. So when you authorize with Spring Authorization Server, this is where it will send you back once you've been authorized, which is a local URI, a local path to gateway. And here you see these message scopes that we need from the authorization server. And here's the URL to the authorization server, and then our gateway configuration. Actually, I lied. I said we wouldn't see any gateway YAML, but here we are. So this is a very simple one. We're just pointing at that resource server on port 8090. If we're using client-side load balancing and something like Eureka or Console, you could do the URL would look like this, where this is just a virtual host. It's the name of the service that you would have registered. But just for a demo, just a static URL. Okay. So let's go ahead and start the gateway. So Netty started on port 8080. Now let's see if I can make this work. So here we are. Let's make that a little bigger. Port 4200, so this is our Node.js application. Go ahead and make sure that's refreshed. I'm just going to hit this link. And so now we're on localhost port 9000. This is the Spring Authorization server. User 1 and password. And then we get our consent screen. We'll go ahead and give, right, these are the same scopes that we've seen both in the authorization server configuration and the gateway that it is requesting. Go ahead and submit that. And then the token was relayed to the resource server, and it validated that token with the authorization server, and we had the appropriate scope, and so our data was returned. This is a fairly complex demo for just something this simple, but I thought it was very informative as Steve was walking me through it, talking about these little bits and how they all work together. But once you have it, it's really, really nice to be able to just have that. Your resource servers, they just need the JWT token.
Quick question on your gateway server. Where are you normally deploying it if you're a Kubernetes? Are you putting that in the cluster as well?
You can. Yeah, this is regardless of what IaaS you're running, whether it's Kubernetes or VMs or anything. So it could definitely be just a service in Kubernetes. Yeah.
Is that how you normally run it? I mean,
There's people that run it in Cloud Foundry. There's people that run it on Kubernetes. We have two members of our team back here that run the commercial gateway. In fact, focused on gateway for Kubernetes right now is their major focus. So we have a commercial product that is actually working on having gateway in Kubernetes. So
if the gateway is forwarding to other services running on Kubernetes, it makes sense because it would be in that cluster discovering the services, right? So.
Yep. One of my colleagues even made it an ingress server at one point, but we haven't gone down that route too much. But yeah, typically, like I said, in the I was here, right? You could have some other gateway in front, right? So if that's the Kubernetes ingress, right, that could happen. But again, ingress is owned by the operations team, right? This Backend For Frontend is typically a developer team that owns it. So, great question. Any others? So that's Backend For Frontend. I think we're done with that and authorization server. Again, 2 o'clock later today, and you can go visit the author of the Spring Authorization server if you want to know more information about that. It does a lot more than I've shown, and you'll get an update on the roadmap and support and things like that. So next, rate limiting. So this is request rate limiting. So as users make requests through the gateway, and there's a number of reasons to do rate limiting, right? This could be a commercial thing where, yes?
Sorry to cut. So you started the discussion that the gateway is on top of the Spring reactive stack.
Yes.
So you cannot use it on top of Spring.
No, so that's one of the differences between Gateway and Zool, though I do have a proof of concept that may, depending on how much time I have towards the end of the year, it may make it in so that there would be an option for Gateway on Spring MVC. Yep. Good question. So rate limiting could be, your user has paid and they get so many requests a second. It could be a resource thing, right? You're guarding your downstream resources. They can only handle so many requests. There are various ways and things to do rate limiting for. Oh, sorry. Get back here. So when we were looking at rate limiting, Stripe is a payment company. Anyone heard of Stripe before? You've probably all used it if you didn't know, because something you bought online may be using their API underneath. But they're a pretty popular company, and it's very important to them that their payment APIs stay running, right? So their clients are rate limited. And they blogged about it, and they described how they were doing it. They use the token bucket algorithm. If you want to go read about it, it's a fun read. And the reason it's called a bucket is because they use a visual, just like a bucket. And every second you get so many tokens that get dropped in the bucket, and it has a capacity, right? So make it to the point where the bucket is full. But then as users come, if they have a token in the bucket, they can make a request. And so that's the whole idea. So tokens get added, and you can configure it such that if a user hasn't used all of its tokens in the allotted time, you can build up an extra buffer so that later, if you have a burst of requests that might happen to be over your normally allotted requests per second, you have a buffer that you can use. So it's a fun read. They also described how they used Redis and Lua to do this. So one of the interesting things, so Lua is a scripting language. You can use it to kind of extend Redis, if you will, or write more custom things that end up running in Redis. But a Lua script in Redis is atomic. So all the operations that happen in that Lua script, they all happen or none happen. And so they use that to do a bunch of calculations and set a bunch of different keys, and then commit them all at once. And the algorithm requires a key, right? That might be a header with, some client ID or something like that, or an API key. We're going to use the Spring Security principle in this particular demo. So this is what it looks like. I'm just going to use, so I do this in all my talks. If you don't learn anything today, here's a new tool. If you've never been to one of my talks before, it's called HTTPy. It's a fantastic command line HTTP client. I call it curl for humans. Anyway, that's what we'll be using to make the requests. That'll be our client. So if you've never heard of it before, you've got a new tool in your arsenal and you gained some knowledge today. So we'll have the gateway. It will be configured to point to Redis. And then our downstream service, I don't actually have another service. I'm just calling the gateway itself, but it really doesn't matter what this is in this particular algorithm. So back to IntelliJ. Let me find the right one. Okay, here we are. So, Sergey, you'll be, yeah. So the company behind test containers is, we've got CEO. Are you CEO? Just developer. Anyway, they're right here. Here. So basically, I needed to have Redis running, and I didn't want to run it on my laptop. I like to have demo self-contained, so all you need is Docker, and I'm using test containers here in my application to get Redis for me, so I didn't have to have it running. So as I start the gateway, there's test container stickers here at the front if you want. So I do this little bit here. So I get the IP address and port of the container and pass it to my Spring Boot application. So, all right. So let's start here. Let's start with the route. So I'm going to do a route. Give it an ID. This is limited. I'm not a professional live coder like Josh. I don't know if you've ever seen Josh Long live code, but it's crazy. So I'll try and muddle through this here. So we are going to match on the URI, which is just messages. So, oh, let's see. I think I did /hello. And we're going to add, sorry, that's path. So we'll add some filters. We are going to say, I'm going to prefix the path with /myservice here. And do request rate limiter. All right, what's the problem? What am I missing here? There we go. So then the URI is just pointing to myself. That's the port of the gateway. So I'm just forwarding this request to myself. It doesn't really matter where it is. One of the things I'm going to do is configure the rate limiter for a demo, just so that the time slot for request rate limiting is a second, right? So I'm going to configure the rate limiter for this particular route. So this is the same key. And the replenish rate, that's how often how many tokens get put into the bucket every second, right? And the burst capacity is the size of the bucket. So just 1 to 1. So you wouldn't look like this in a normal thing, but just so we can see the demo, we're going to do that, okay? So the next thing that rate limiting needs is a key resolver. So this is something that says, in Redis, I'm going to store how many requests, how many tokens you have left, and all that stuff, so that if you have multiple instances of gateway, they are all looking at the same data, right? Because if you did this in memory and you had multiple instances, if they happen to hit another instance, right, they could get through when they may have actually hit their limits. I think someone on the gateway team, let's see, you guys don't use Redis. What do you use? Hazelcast? Okay, right? So that would be so there's an interface you can implement other kinds of rate limiters, and they've used Hazelcast to do that. So exchange.get principal. Let's see. Principal.get name. All right. So this is just a simple key resolver that gets the principal from Spring Security. So here we are down in Spring Security. We need a user, right? So we're going to do the demo users here, which is just an in-memory user with username and password. Again, it's funny, it's deprecated because you should never use this in production, right? So they made it deprecated even though it's probably will never be removed. So now we need to configure Spring Security. So what we're going to do is all of the requests to the gateway need to be authenticated, and we're going to use for an API, just HTTP basic, okay? So I think we have everything here, correct? So let's go ahead and start this. So that was, all that stuff above was test container starting Redis. All right, let's open a terminal. See how this works. So -H in HTTP, you don't have to put the scheme if it's HTTP. You don't have to put the host if it's localhost. Pretty nice. And it formats things, puts them in color. -H says just show the response headers, so I don't show the body. And then, of course, this is how to do basic auth, and it will encode it properly for you. So here we can see a number of headers that were returned that describe the state of this particular user's rate limiting tokens. Okay, obviously, if I didn't have this guy, I'm going to get a 401, right? The other thing that we try and do, if Redis is down, we're just going to assume that the user has enough, and so we would let them through. So now let's see if we can get this to show you to be limited here. So watch is just a pretty common Unix command. It says keep rerunning this command over and over. -N, we're going to do it every 10th of a second or so. And we're going to use this same URI. And the reason I showed -H is so that we can see basically the return status. And we should be able to get a different 400 level error as we go along. So you can see about every other request is a 429, too many requests for our demo. Okay? So that's rate limiting with Redis. I love it. I've done 2 demos and they've both worked. So this is, if I fail here on out, this is still a good thing. But 2 for 2. I shouldn't have said anything, shouldn't I have? All right. So next we're going to talk about Monolith Modernization. So all companies have, I don't like the term legacy, heritage, right? These are the things that are actually making your company money, right? That have been around for years or even decades, right? But sometimes they need to be modernized. Doesn't make sense to add it to the older applications. So sometimes it makes sense to add new services. But how do you do that and keep the monolith valid, right? So we'll talk a little bit about that. I tweeted that this was going to be starring today, so if anyone doesn't get the reference, come see me afterwards. I've got a movie you need to watch. In fact, I have it here. So level 0, this is the existing state, right? Your clients connect directly to your monolith. So step 1 is to put something between your clients and the monolith, right? But don't change anything. Don't change their behavior, right? To the clients, this looks like nothing happened. So we'll put a gateway here in between and just forward everything on to the monolith. That's level 0, and it's an important step because this now allows us to carve off little pieces of the monolith, whether it's a new API or re-implementing an old one with new features. So then we add another route. So we have a new service, and then we route it before going to the old monolith. And we can do that indefinitely, and the monolith either eventually goes away or it gets to a state where it's easier to manage. So back to IntelliJ. How are we doing on time? We're good. All right. So in this example, we'll start with, let me show you my dependencies though. So again, pretty basic Spring Boot application. This one we have time leaf just to show a little UI in the monolith and gateway. So this is our simulated monolith application. This is a WebMVC controller. Actually, it may be WebFlux, I don't know. But basically, this one just shows a UI, right? So we have an index.html file, and then it has a few APIs, okay? I just put them all here in one class just so it's easy to see, but this is our monolith. So the monolith is running on port 9070, so let's go ahead and start that guy. Okay, Netty on port 9070. So this is a WebFlex app, but it wouldn't have to be. It doesn't matter. Whatever the services are downstream, they don't even have to be Spring Boot applications, right? They can be anything that accepts HTTP traffic. So let's go ahead and HTTP 9070. So by default, we get our little bits of HTML from our template, but then we have API 1, hello, API 2, you get the picture, right? So this is our monolith. So now let's go ahead and put a gateway in front of it. So here is our gateway application. So these are all in one project, and I use this Spring Profiles Active to set up different properties, right? So the gateway will be running on port 9071. So I've already set up my route locator here, so let's go ahead and create a route again. So monolith, and this is going to be a pretty simple one. The path, so I need to put a string in here, is just everything. Again, we typically probably use some load balancing here, but since it's just a demo, localhost, what did I say it was, 9070? Yep. 9070, right? So this is putting the gateway just in front of the monolith. So now if we start gateway application, so there we are, started on port 9071. If I go back to my terminal and just change the port on these guys, we'll get all the same things, just now running through the gateway. Make sense? Pretty simple so far. So now I have created a new application, API application 1. We'll go ahead and just grab our mapping here we're going to migrate it here. So this is now our new thing. So this is from standalone, right? So this will be running on port 9072. Go ahead and start that one. So now we need to go back. So now that thing's up, now we can go back to the gateway and add a new route for API 1, right? So we say API 1, and the path is API 1, and it's running on 9072. Again, usually put a service here and have some kind of service discovery. And so now, this is important to be at the bottom of the list, right? So the gateway, as it looks at the routes, it matches them in order. So it will match API 1 first, and then the monolith. So now if we restart the gateway, back to our terminal. So if we go to the home page from the monolith, but now if we go to API 1, we get the new values. So this allows organizations to modernize, but you don't have to do the big bang approach, right? You can do this at your own pace, and however comfortable your organization is with modernizing your monolith. All right. So back to presentation. So our last little bit that I'm going to show is scatter gather. And this is one I've wanted to demo before for a long time, but I haven't. So what we've seen up until this has been Spring Cloud Gateway server module. There are a couple other modules in Spring Cloud Gateway. They're called Spring Cloud Gateway WebFlux and Spring Cloud Gateway either MVC or WebMVC, I can't remember. But these are kind of lightweight gateways, and I'll show you what it looks like here in a minute. But this particular pattern is fairly common. This would be useful probably in a backend for frontend, right? So backend for frontend, you want to get requests from multiple services and then combine that data into a single response, for example, for your client, right? So pretty popular thing. So we're going to be using this Spring Cloud Gateway WebFlux. I'll show you what the proxy exchange looks like, this class. And interesting, it can be combined with Gateway Server. So everyone done taking pictures? Almost. You good? Perfect. So back to IntelliJ. See if I can find the right. It's going to be the last one. Okay, so here we are. So in our POM, again, Spring Boot, Spring Cloud 2021. So here's the starter that we've been using this whole time, right? Spring Cloud Starter Gateway, but we're going to add a new one, Spring Cloud Gateway WebFlux. And what this does is it configures WebFlux or WebMVC, if that's the case, to have a new type that you can add as a parameter to your controller methods, okay? So in our case, if I come back here, we have a couple of different services downstream. We just have 2, I think. And again, they're static. They just say service 1, service 2. Let's see what port those guys are running on. 9061 and 9062. Okay, so here in our gateway application, to REST controller, I have a Git mapping at this path. But here you can see this new class. It's called Proxy Exchange. This class is set up to be able to help you make requests to downstream services easier than just using. So in WebFlux, it uses Web Client underneath the hood, and WebMVC, it uses REST template under the hood. You could certainly do everything I'm about to show you with Web Client, for example, right? But this is just a helper to get that done. So proxy.get, let's see. Do the URI first. So localhost 9061. Did we have a path on here? It was just the root. Okay. So we're just going to call git. Oh. I been using a Mac for a while and I've all of a sudden forgotten some keys. All right. Oh, come on. All right. We're just going to do this. So I'll just walk you through what's happening here. Just ignore this for a little bit. So what we're doing, we're just doing a couple gets on both of our services. And what that returns is a couple of monos of response entity, right? Response entity is just a Spring Web. That's a normal thing, right? This allows you to get the headers, the response status, as well as the body, right? But we have these monos here. No, it's not a disease. Sorry, bad joke. So this is from Project Reactor. So at this point, there has no work has been done. This is basically a template for the work that should happen as soon as these reactive types are subscribed to. Does that make sense? So these things haven't happened yet, but we need both of them. So what we're going to do is zip them together, okay? So this says, wait for both of these things to complete, and then put them in a tuple, a two-tuple here. Wasn't there a Spring tuple project at some point, Mark? Yeah. Anyway, this tuple comes from one of the framework guys, the old Spring framework guys here in the back. This is a reactor tuple, so we can say, we need to do this so that we can, after it's subscribed and both of the responses have returned, right? They may take different amounts of time. So we get both of our responses, and now I'm just going to combine them, right? This is where you could do it in whatever format you need to. I'm just going to do it, just combine these two responses. So right now they just return single strings, but this method is going to return an array of strings, a JSON array, right? I need to set a value, basically saying, hey, we're returning JSON. And then here I build our response. So status code, I just picked response 1 and its headers, and then the body, which is our list, okay? So let's go ahead and run our services. So service 1, service 2, our gateway. Come to our terminal here. Let's see. So if I show you 9061, right, just returns service 1, plain text, right? So the content types are different, right? So this is just an example. If you're returning XML from one service, but you want JSON, you could do that. You could do that in this thing. All right, so the gateway is running on, forget 9060. Okay, so if I come back here, 9060, we called it scatter gather, right? And there we see now we get to see some pretty formatted JSON here, right? So we've combined those two responses into one. Now what happens, say you've done this for things, but you have a bunch of filters that your company has for security, you want to go through gateway server. Well, you can certainly do that. We could certainly build a route here. Let's just go ahead and do this. So we're going to call it scatter gather, but we're going to change, right? So we have some particular API URL that we want. And instead of going to some downstream service, we're going to use this special scheme called forward, okay? And it's just going to forward to a local controller. So if I restart, oh, that's not the one I wanted to restart. If I restart the gateway then, and come back to the terminal, and we can then do /API, and all those filters that you apply to all of your gateway routes would work, right? So, and we just forward to the local thing. So we could manipulate paths and headers and all sorts of other things using the standard. So some of the other things, well, we've got a minute or two here, some of the other predicates that you could see are, so after, before, cookie, headers, host, methods, all those things. And in the Java DSL, you can use Boolean, right? And, ors, nots, where in the YAML and properties, they're all just anded together. They all have to match, right? So you could be a little more flexible here. And in filters, the other filters that we have built in, we showed rate limiter. You can prefix the path. There's a circuit breaker. Used to be Hystrix. Now by default it's Resilience 4J, but there's also support for others. You can add headers, parameters. You can modify the response. You can redirect. There's all sorts. You can do retry here. There's all sorts of things you can do. Yes, we saw token relay earlier. You can do all that in the Java DSL. All right. Hey, 4 for 4 demos. They all worked. So, but we've come to the end. So these are the URLs of the where all these demos are. Yes, any questions? If not, thank you very much.